there's a gauge pressure of 812 torr at a depth of 14.2 meters in a fluid. What's the density of the fluid? Assume there's 1 atmosphere above the fluid. There we go. Okay, so here's this fluid. Let's draw this. Okay. Now we got some density down here, and we are 14.2 meters down in this fluid, right? There's some pressure up here, right? 1.013 pascals up here, and then the gauge pressure down here is 812 torr. So I'm going to figure out the absolute pressure down here. So I'm going to go 812 plus 760 and get the actual pressure. There's another way to do this, but I'm trying to use the formula in the data pack. So 1572, and then let's figure out that in pascals. 1572 over 760 times 1.013. So divided by 760 times 1.013 and the pressure down here is 209,531 pascals. Quite a lot of pascals, right? Okay, so now we're set. Now we can use our pressure formula, right? So pressure is pressure above the fluid, right? And this is our pressure, right? Plus rho GD. I like how they end in GD. Okay, so 209,531 equals 1.013 E5 plus the density we don't know times 9.81 times 14.2, right? There's our thing there. Okay, so now I'm gonna subtract an atmosphere 1.013 E5, and now I'm gonna divide by 9.81, and I'm gonna divide by 14.2, and I get 776.9. Okay, so that's way number one. Okay, way number two is to go, okay, if the gauge pressure is 812 torr, the gauge pressure simply is equal to rho GH, right? Okay, so I'm going to go 812 divided by 760 times 1.013 E5. That's simply rho times 9.81 times 14.2. This also works. Okay, so I'm going to go 812 divided by 760 1.013 times 10 to the fifth divided by 9.81 divided by 14.2. And I get exactly the same answer, right? But they give you this fancy formula for hydrostatic pressure, which includes the pressure above the fluid. So yeah, there you go. So if you're just trying to find the gauge pressure down here, right, that pressure is just rho GH. Right? Or if there is no pressure above the fluid, there it is, right? Or H is this distance. All right.